Welcome back. Let's dive into security requirements. What is a requirement in engineering? At its core, a requirement is a statement that defines a specific functionality or capability that a system must have. For example, a vehicle may have requirements like shall transport people from point A to B, shall support at least 4 passengers, must operate in any weather conditions. These requirements are essential for ensuring that a product meets its design and operational goals. Requirements can be categorized into various types, including functional, design, safety, operational, and quality requirements. Each type focuses on different aspects of system performance and compliance. In this slide, we see a set of requirements. Based on these requirements, what would be the requirements for? One of these transportation mechanisms should fulfill the requirements of shall transport people from A to B, shall support at least 4 passengers, passenger must be able to travel in any weather condition at a consistent speed, journey must not depend on air or water channels, cost of travel must be less than $0.25 per mile, must not emit carbon byproducts during normal operation. The answer is these are requirements for a BEV or HFCEV hydrogen fuel cell car. Now let's shift our focus to security requirements. A security requirement is a specific statement that ensures the security properties or objectives of a system are satisfied. These requirements aim to address or eliminate specific vulnerabilities. The cybersecurity goal is broad and focuses on what needs to be protected and why, for example, ensuring the integrity and confidentiality of CAN bus communications. The cybersecurity requirements are specific, actionable steps that define how to achieve the cybersecurity goal by implementing technical controls and security measures. For example, if we have an application that allows users to navigate a system, a security requirement might be to secure the portal, all coordinates must be encrypted and access should require a unique biometric scan. This ensures that only authorized users can access sensitive data, protecting against unauthorized access. Some examples of security requirements may include access to the portal app must require a successful biometric scan, for example, fingerprint, facial recognition, to verify the identity of the user, and more. These may still be high level compared to the security requirements that are required to be developed within your organization. Technical security requirements are more detailed in nature, as they should be. How do we go about defining security requirements? Here's a structured approach. First, develop a high-level functional model of the system to be analyzed. 2. Identify potential security threats that could impact the system. Third, classify the risks associated with those threats. Number 4, assess the impact to prioritize mitigation efforts. And under number 5, we have derive specific requirements to mitigate the identified risks. Note that the first 4 steps are typically completed during the TARA process. This ensures that our security requirements are aligned with the actual risks identified in the system. The objectives of setting security requirements are multifaceted. Maintain operational performance. Ensure that all vehicle functions continue to operate as intended, even under potential cyber threats. Secondly, ensure safety. Protect not only the vehicle occupants, but also other road users from risks related to cybersecurity incidents. Number 3, protect privacy. Safeguard the personal data of vehicle occupants and the intellectual property of manufacturers and suppliers. And number 4, we have prevent fraud and theft. Ensure that systems are secure against fraudulent transactions and unauthorized access that could lead to vehicle theft. Now let's discuss cybersecurity assurance levels as defined in ISO SC 21434. CAL specified the level of assurance needed to protect automotive assets. They don't detail specific technical controls, but instead provide a common language for assurance needs across the development lifecycle. CALs help guide the cybersecurity effort within TARA by setting early assurance levels based on the criticality of assets and the potential threats. Unlike TARA, which focuses on dynamic risk assessment, CALs are static and provide a consistent baseline throughout the development process. Integrating CALs into TARA enhances the process by linking assurance levels to risks. This ensures consistency in addressing critical threats while maintaining TARA's flexibility. Assigning CALs to risks creates a robust framework for managing cybersecurity across components, even when multiple suppliers are involved. These are the various stakeholder types. Depending on the stakeholder, your approach and what you want to analyze or emphasize in the TARA may be different. Creating a strong connection between service providers, OEMs, and the supply chain is essential. Regulatory authorities require organizations to demonstrate compliance with standards like ISO SU 21434, which means that everyone involved must generally be aligned on the cybersecurity requirements. Let's talk about the relationship between cybersecurity goals, claims, and requirements. According to ISO SU 21434, cybersecurity goals are concept-level requirements that align with threat scenarios. Cybersecurity claims specify how these goals are to be achieved. Requirements provide the implementation details and architecture needed to meet those claims. When in doubt, always ensure that your cybersecurity requirements relate back to a defined cybersecurity goal. This ensures that your security efforts are focused on the most critical aspects of the system. Here is the reference to definitions defined in the standard. Setting clear, actionable requirements, especially for security, is crucial in developing secure automotive systems. By aligning requirements with identified risks, leveraging cybersecurity assurance levels, and collaborating with regulatory authorities, we can ensure that vehicles are not only functional, but also resilient against cyber threats. Let's recap. In this training, we covered many areas starting from introduction and foundational knowledge, diving into the TARA steps, and covering additional topics such as cybersecurity claim, goal, and concept. Our practical examples include a walkthrough of 2 TARAs from start to finish, so be sure to check out those videos out as well. Also, feel free to look at some of our blog posts, which you can find on our website. Don't forget to also take a look at some of these solutions and products that we offer. We highly value your feedback and invite you to fill out the feedback form at the end of this course. Here you will find a reference slide full of resources that we used to conduct this training. I hope this training was informative, and if there is a topic you feel we did not cover and want to learn more about, or just have some general feedback, feel free to reach out to us to provide feedback. All training materials are included in this course, including the slide deck, in addition to templates and reference guides. Thank you.